Nice to meet you. My name is Hwanyong Lee from Korea. I think we just have 3 guests. So have you ever heard about the OpenVG? This is first time, right? Okay, good. So Khronos has some kind of a API, graphics API family. And OpenVG is 2D vector graphics standard API. So it can be used for drawing any kind of application or high quality 2D vector drawing possible. Okay, and so OpenVG does not have any kind of loyalty, and it has a low-level 2D vector graphics API, and the command syntax is very similar to OpenGL. So if you are familiar with OpenGL, then easily you can learn OpenVG. And OpenVG is designed for supporting SVG, special SVG, tiny and Beijing, and flashlight player, and PDF, and PostgreScript, and some kind of a Java interface like JS 226, 271, 27. And OpenVG is very good for implementing portable contents and web application, and OpenVG is designed for we assume that we will hardware accelerate the OpenVG features. The OpenVG rendering pipeline is defined like this. The first step is the pass and transformation and painting stroke definition. So the pipeline stage 1 is the programming stage. So we define some object and drawings, and then the trigger command, the draw command, and then the pipeline goes to next step. So stroke path generation. So we make with the stroke parameters like the end cap shape or join shape, and the line width and dash pattern, and we make some view, the outlined the shape of as a result of a stroke path generation. And then third step is we do transformation. And then first step we make some kind of a the grayscale. We make grayscale image that as a result of the coverage of each pixel, the polygon, how much the pixel is charged into polygon. Then that result is used for calculating the anti-aliasing function. Okay, so and then stage 5 we are doing the clipping or scissoring, and then stage 6 we make paint generation, and then in 7 we do some image related processing. In 8 we are doing blending and anti-aliasing features. Like OpenGL or OpenGL, yes, OpenVG is big state machine. Then we make input data like path data, image, and paint parameters, and we can make font or mask. This 5 object is the major, the handle object in OpenVG. And as a result, we will make some kind of, we can make path, or we can as a result, we can generate image, or we can generate mask image. In general, as a result, we draw something in canvas. So, and we should, to draw something, then we should define in context, or we can use some additional command. So we define the stroke parameters and fill path, how to draw path, how to draw image, and which blending is used for drawing, transform, and we can do some kind of adjust color by color transformation, and then we can set up the scissoring and masking parameters. Then, if we trigger the command, then the result will be generated by random. Okay, so in path we can define path with the straight line and Bezier curve, two kind Bezier curve, quadratic Bezier curve and cubic Bezier curve is possible. And then we can use the elliptical arc segment to define paths. We can use the absolute or the relative coordinate system, and then we can generate a new path with the path interpolation or path transform. And we can use the path related command like we can calculate bounding box or transform the bounding box, or so we can calculate the tangent vector over specific point or position, and then we can get the point position of a specific lines. In case of stroking, we can define that some line width and handicap style. Handicap style, there is three kinds of handicap style: the round, butt, and the square shape. And then there are three kinds of line joint styles: bevel, round, and meter shape. And we can also define the limit of meter. So because the meter can be very long in case of two line segments meet almost a straight line, then it will generate a really long meter. So we can set that if this meter length is over the limit, then it will process with like a bevel. Okay. We can also define dash. Okay. In case of transformation, we can use two kind of transformation, but we can use the perspective transformation only for image transformation. Okay, so the other transformation we can only use the affine transform only. So there are 5 kinds of transformation. It means that there is in context. In the internal rendering, there is 5 matrix. So I say that there is only possible the perspective transform is possible in transformation of an image user to surface. So this matrix also 3x3 matrix, and other matrix is 2x2 matrix, affine transform only. So there are 2 matrices in the painted to users. So one is a field paint to user matrix, and second one is stroke paint to user matrix. And then we can draw 3 kinds of objects in OpenVG. The first one is path, second one is image, and third one is script. We can say that font. So the 3 different objects should be transformed separately. So we should have 3 different matrices: the path user to surface, image user to surface, and script user to surface. I say again that the image user to surface, only this matrix can contain the perspective transformation. Okay? And rasterization, we calculated the coverage of each pixel, then it will be used for anti-aliasing calculation. Then scissoring, we can define at least the 32 the rectangle to in screen coordinate. So we can define that this area is used for drawing. In outside of this rectangle, the drawing is not occurred, and inside of this scissoring rectangle, the drawing is occurred inside of the scissoring leg. Okay, so if we define that the 1, 2, 3, 4 scissoring leg, then if we draw the green arrow like this, then the result will be like this small triangle and small square and another shape. The 3 shape will be displayed in the screen. Okay, it will be very useful to. We can set the region to draw. For example, if we draw some GUI or cellular, then if in case of just the antenna shape of the gauge to change, but we don't have to. Then you don't have to change the whole screen, so just a small area. And we said that the scissoring light in there, then we draw the GUI again, then just the antenna shape will be redrawn only. No, nothing changed. So we can use it then. And mask is we can define the draw or not by the pixel by pixel. So if we define pixel as a 1.0, then the drawing will occur in that pixel. If we define the pixel as a masking pixel as a 0, then it will not drawn. And if it is 0.5, it will be the blended onto the existing image. Okay. So, and in masking, we can add something in existing masking, or we can remove something from existing mask. So there are clear operation, pair operation, cell operation, intersect operation, union operation, and subtract operation. And we can change the mask by the combination of the mask operation. Then we can make this kind of things. So, for example, we can add more mask than so we can use for the union of masking. And there is another special case of making mask images, the render to mask. We can draw something, then we can use the alpha channel as a mask image with this kind of mask operation. So this example is we draw the star shape with even odd fillable. Then with that alpha value, I said that it is a masking. I said that the result image is mask. Then I turn on masking, and then I draw the full screen of a flower image. Then we can get this kind of result image. Okay. Paint generation in OpenVG, there is 4 kinds of paint is possible. So one is solid color painting. Second one is linear gradient. Third one is gradient. First one is the pattern peeling. Okay. Pattern peeling is a peel the image onto the shape. So and there is some kind of parameters of each the paint object, and we can, in case of linear gradient, we can set that we can repeat the gradient and again, and we can reflect and repeat the gradient like this. And pattern, of course, it is possible to the other area filled with a solid color, or pattern is repeated, or pattern is padded, or pattern is repeated, or pattern is reflected is possible as a parameter of the pattern painting. Okay. And okay, I say again that we can draw 3 kinds of objects. One is path, second one is image, third one is font. And second object, the image. In case of we draw image, then there is 3 kinds of drawing mode. One is normal drawing, second one is multiply mode, third one is stencil mode. The normal one is just drawing the normal image onto canvas. So it's very easy. So like this. Second one is multiply. The multiply is drawing image with multiply with paint image. So it is the source image, and then this radial shape, the ball shape is the paint. Then result image will be like this. It's a multiplied image, and then multiplied image. If this multiplied image is blended on white screen, then the result will be like this. And the stencil is we know that the stencil is passing some colors by stencil filters. So if we define image as a stencil, then if you define paint, then the stage color, if it's station in stage buffer it set a color, then that color, only that color can pass into the canvas, so we can get this kind of result. So sometimes it is very hard to understand this kind of effect of a stage buffer intuitively, but if you try and if you do the experiment, then you can get some kind of result of what you want. Okay, so and then there is some image APIs for the processing image. For example, there is some kind of child image feature. It is very useful to drawing GUI. For example, in GUI there are so many the icons we use. So we made a big image and we sliced it into a small image as a child image. Then we can make it more more easily, and we can transform each child image. Then we can get really good performance. And there is another thing that the image convolution filter is possible in OpenVG. So you can define kernel, and then you can do image convolution with that kernel. Then you can get this kind of edge detection, image processing, or some kind of the enhancement or blurring effect you can make. And we also possible to make image filters with lookup table, and we can change. We can make some kind of graph with for each RGB color. Then we can make this kind of metallic effect. Okay. Blending. If we learn one path, one route of pipeline, we generate some temporal. We generate some image, and then that image should be the overlaid on the top of existing canvas. So, for example, we draw something. We draw a triangle in this screen. Then the triangle should be displayed on existing screens. So we can call it as a blending. So there are three kinds of blending existing in the OpenVG. The number one group is the portrait of the blending functions. Second one is some kind of a darken or lighten image and multiply image. And additive blending is possible in OpenVG blending. The total 8 kind of blending function. Okay, I'll show you. There are so many pictures because okay. Left one is very general blending function. So we can assume that we just finished that drawing the S image, and then the D image is we already has that result. That is destination canvas buffer. So, and then if we blending with the source, then the third, okay, this image will be generated as a result. And then the most general case of the blending is source over destination. New generated images on the top of existing images. So this one is the most general case of blending, source over destination. And we also go to new drawing. New drawing is go to behind that existing image, the destination, then destination over source. Okay. And we can draw on the top of a destination. So source in, destination in, and you can do multiply. So green and blue does not have an intersected value, so we can get some kind of zero value in these areas. So we can multiply, or screen feature is kind of a stencil features, And then we also can do darken. We can choose the lowest value. We can choose maximum value, and it will be, we can get lighten image. Then we also can get additive. Additive is just additional to value of a source and destination. But it looks very simple and very intuitive. But in case of we mix use with multiply image drawing and stencil image drawing, the result is very complex. So, for example, this is multiply. So multiply is quite easy. So if we paint images, if painting image, we can assume that the paint image is flower, then flower image will be multiplied with source image. Then the last result will be very similar to without multiply image. So, but the problem is stencil. If we define drawing stencil image, then the definition of a blending function is changed. So you should really calculate the equation of blending over in case of stencil drawing. So then you can use it. But in general case, the stencil using stencil with the special blending feature is a very special case. So I think it will be very rare case of some normal application, I think. And another thing is the people drawing, the people branding, we can do color transform. Okay, so color transform is just, we can control each RGB alpha color by the scaling and translate that we define the scale value and bias value. Then we can make like this, the color adjustment like the darken or lighten or inverse color. And then we can make, if we change the opacity value, I mean alpha value, then we can get some kind of some fade in, fade out effect or the dissolve effect. And font. Many people ask to me, how can we draw character in OpenVG? But there is no such way to draw font. So, I mean, there is no font system in OpenVG API. But there is some API for making font system. Okay, so if you want to draw some character, then you should buy some font system from some company, and you can connect it with your existing OpenVG engine, and you can draw it. But the font is not included in OpenVG system. Okay, so OpenVG can be implemented with OpenVG chip or software, or we can use OpenGL ES hardware to implement OpenVG. But we should translate each polygon into triangle. So sometimes it is very time-consuming and so CPU-intensive works. So sometimes it makes result over some this rendering performance is much more slower than software-only rendering. So you should use it carefully. And we can use some image rendering system to accelerate OpenVG. Okay. This is some relationship between OpenVG and other technologies. Like so we can implement OpenVG on the top of GLES, but it is not possible 100% CTS past version. We cannot make it. So now we are making some OpenVG Lite pilot can be implemented on OpenGL. And some commercial products like Google Skier can be accelerated on OpenGL, but in case of Adobe Presslight Player, Lite version can be accelerated on OpenVG, and version 10.1 and 10.2 can be accelerated on OpenGL. In case of Nokia, Nokia Qt, the GUI platform can be accelerated on OpenVG, and BlackBerry JDE, Java Development Environment, 7.1.0 has OpenVG layer. I think this is very special case of OpenVG. So OpenVG has only C interface only, but the BlackBerry developed a Java binding Java interface for OpenVG, so they included in Java development environment. Okay. And HTML5 Canvas Studio implemented with WebKit or GTK or KITE graphics. And currently there is no direct implementation of Canvas 2D onto OpenVG, but they draw something with the software, then they make it some kind of image, and then that image is used for pattern or something, and then it is connected to the OpenVG. So of course it is connected to OpenVG or OpenGL, yes, but it makes the 100% hardware accelerated performance. So somebody should do that, but the problem is we try to do that, but HTML5 WebKit or something is open source code, so drawing command is scattered all around the source code, so it is not possible to separate it from WebKit. If WebKit has some kind of, this part is drawing option, so we can change only this part. So hopefully we can change it, but the status of WebKit source code is not so easy to do that. Okay. So maybe some big company like Chrome or some Opera that kind of company can change the whole source code of a browser. Then,
So is there an accelerated skier?
Pardon?
Is there an accelerated skier, Google skier?
There is, but same as other the WebKit, so it is another 100% the accelerated layer. They draw something with software, then they make some kind of texture or something, then it passed into OpenGL, yes. So, and sometimes they say that it is much more faster than the full OpenGL implementation because, for example, WebKit, you think about WebKit, you don't have to, web page is not animating. So if we just draw one time in the web page, so we don't have to draw again and again. So if draw with the software, then make it image and send it to caching into OpenGL hardware, then you can scroll up and down, moving left and right. It will be very the efficient way to drawing web page. So, game is always changing and we should refresh 60 frames per second, but web page does not have that kind of application. So maybe it will be different in WebGL or Canvas 2D, but the general web page does not have to do that. Okay, I showed some demos of OpenVG. This example is that just somebody, it looks like 3D transformation, but it is OpenVG drawing. So we just sorting that the order of icons, then we can get this kind of shape of a GUI. So, and this is a simple changing of the dash parameter, then we can get some of this kind of animation effect. And then we can draw the vector font with OpenVG. And then we can make SVG player on the top of OpenVG. And then, with the child image, you can transform. This is just kind of filter. And with child image, you can transform each child image. Then we can get this kind of effect of image. Actually, I teach OpenVG for some students, and I give some homework to making some. They made this kind of result in 3 weeks. first quarter is the student phase, their phase. I gave A plus too. So I think that to make understand the student for multimedia authoring or gaming or something, the OpenVG is a very good tool to do that. Okay. Currently, there's an OpenVG working group making the OpenVG Lite profile. It is targeted to making more light profile for can be implemented on OpenGL ES2.2 hardware, and so we'll try to make it more easy conformance test suit to it is purpose. Our purpose is that we can make more wide use of OpenVG, of course. And my company, Hwanyong, will release, as soon as possible, we will release a study kit, the OpenVG study kit. It can be used for PC Windows environment, I made some kind of a coursework PowerPoint slide. It will be opened in Khronos KITE site. I think it will be January. So it will be English version and Korean version will be open in KITE site in January. Okay. Any question? I think that most of each technical issue is fixed, and after that, after making decision of a work group, and then we should make a CTS. But making CTS is not making, or we just eliminate some tests in existing CTS, so it will be very easy to implement it. I hope that people summer of next year, I hope to release CTS and Lite properly document. That question, okay. Thank you very much.